My name is Arnav Chantala, and I will be presenting the infrared spectrometer. Regarding the history of its development, IR spectrometers were developed in the 1940s in order to analyze petrochemicals and other organic compounds. In 1957, the first low-cost spectrometer, the Perkin-Elmer infracord, was created. It covered a range of 4,000 wave numbers to 660 wave numbers. More advanced spectrometers moved from sodium chloride prisms to potassium bromide and cesium iodide to increase the range to 400 wave numbers and 200 wave numbers respectively. In 1969, the Fourier transform IR spectrometer was commercially produced by Digilab. It is the most widely used IR spectrometer in the world today. IR spectrometers can identify samples, do quantitative analysis, and detect impurities. It can determine gaseous, liquid, and solid samples without altering the substance. Other uses of IR spectrometers include chemical analysis, forensic investigations, and environmental testing. On the left is a sample of cyclohexanone that's been run through an IR spectrometer. Though the spectrum has many peaks, their characteristic absorptions of the different functional groups allow the compounds to be distinguished. Cyclohexanone shows a characteristic ketone double bond between carbon and oxygen peak at 1,717 wave numbers, which is between the range of 1,780 wave numbers to 1,650 wave numbers. Regarding how an IR spectrometer works, only the middle of the infrared region of the electromagnetic spectrum is used to identify organic compounds. All molecules have a specific amount of energy which causes it to move. This energy is measured through frequencies, which is a wave number. If the molecule is exposed to electromagnetic radiation, energy is absorbed if the frequency of the radiation is the same as the frequency of the vibration. The specific frequency absorbed is present on the infrared spectrum, so it is possible to determine the types of bonds found within different compounds. Continuing how the IR spectrometer works, on the left is a table of the different types of bonds that can be found in organic compounds and its specific wave number range for those types of bonds. And basically it just shows how much infrared energy that this types of bonds absorb, which makes it easier to put on the graph and look at the peaks that were found in the earlier sample data. Functional groups have characteristic infrared absorptions that do not change from one compound to another. For example, the carbon and oxygen double bond mentioned earlier from ketone is almost always in the range of 1,780 wave numbers to 1,650 wave numbers.